Yeah.
So we're going to talk about this basic stuff. Basically, fractions, decimals, and percents is what we're doing today. So this part right here, we'll talk about operations on rational numbers, and of course, generally we know rational numbers is fractions. So we'll start with addition and subtraction, and we'll start with the easy case, right? So if you have 2/7 plus 3/7,
Yeah, 5/7.
right. This is straightforward. You're dealing with the same denominator, so you can just work in the numerator. So here we're adding, so you just add the numerators. 5/7. All right. 5/11 minus 7/11. Again, it's just going to be, we're just dealing in 11ths, so we're just dealing in over 11. So you can do 5 minus 7, so that's -2. So one thing that you should be aware of is that there are different ways to write out the answer to this problem. So I put 2 of them on the board right here. You can either put -2 divided by 11, or you can simply write it as 2/11 with a negative in front. So these are 2 different ways of writing what is exactly the same thing. Does that make sense? Okay. So another way to see this is with a simple fraction that we know how to work with. So if you have a negative in front and then you have 8/4, well, that just simplifies to 2, but then with the negative in front, so it's -2. And notice that you would get the exact same thing would happen if you had -8 divided by 4. Again, that just gives you -2. So you could have the negative on top, you could have the negative in front, you could also have the negative in the bottom, but we never write it that way. So is that straight? Okay. Now, 4/9 plus 1/5. How do you do this problem? LCD, but yeah. Right. And what is the LCD in this problem? Sorry? 45. Right. In this case, it's easy to find the LCD because it's just going to be one denominator is 9, one denominator is 5. So the easy LCD in this case is just 9 times 5, which is 45. Now, how do you use the LCD to go ahead and solve this problem? Sorry? So what happens to the first fraction? Right. So I'm going to write it out real slow. So we want the bottom to be 45, so we're going to multiply by 5. But we have to balance that. So how do we keep it balanced? Also do times 5 on the top. And now the second fraction. What do we have to do to the denominator? Not the same thing. What do we do? Yeah, times 9, because we want to get it to 45. But anything you do on the bottom, also have to do on top in order to keep the fraction balanced. Alright. So this is 20/45 plus 9/45, and that we know how to do easily. So it's just 29/45. Okay. So again, the idea here is that we're keeping things balanced. What you do on the top, you must do on the bottom, and that preserves the fraction. we often think about this going the other way where we reduce, right? Because 3/6 is the same as 3/6 is the same as 1/2. Now, how do you get 3/6 to be the same as 1/2? Right, we divide by 3. So what we're really doing here is the exact same thing, but in the other direction. Instead of taking away the 3 from being there, instead of removing the 3, we're putting the 3 back in. Or in this case, we're putting in the first fraction, we're putting a 5 back in. Or in the second fraction, we're putting a 9 back in. And the reason we're doing that is so we have the same denominator. Okay. So, similarly, 1/4 minus 1/6. What do you need to do? Okay? LCD. Now, what is the LCD going to be? Okay. Well, a CD will be 24. But 24 is not the lowest common denominator. What's the first number that both of them go into? Yeah, it's not 24, it's 12. Alright. Now, truthfully, when you're doing problems, if you use 24 or use 12, it doesn't really matter because you're going to reduce it anyway in the end. But if you're being asked what the LCD is, the LCD certainly is 12. 24 is extra stuff we don't need. So what happens to the first fraction? And then in the second fraction, times 2 on the top and bottom. So you get 3/12 minus 2/12, 1/12. Okay. So that is addition and subtraction with fractions. Any questions? Okay. So now let's mix it up. Multiplication and division. Alright. Well, I would say that strangely this is actually easier. When you're dealing with fractions, multiplication is actually easier. Because what do you do if you have 3/7 times 2/9? You just go straight. So you just have 3 times 2 over 7 times 9. And 3 times 2 is 6, 7 times 9 is 63. And now we do the reducing that we just talked about before. There's a 3 in both the top and the bottom. So this works out to be 2/21. So this is one way to do the problem. But there's another way that sort of, I guess, keeps the numbers smaller or simpler. So what's another technique that we can use to do this problem? What do you mean by cross multiply? You don't do 3 times 9 and 7 times 2. Yeah, so I'm going to come back to this cross multiply thing in a second. But yeah, instead of waiting until the end to cancel or to reduce, you can do it in the first step. So in the very first step, you look at the 3 and the 9, or in the second step if you like, you say I'm going to have 3 on top and 9 on the bottom, but I know that that reduces immediately. So you divide out by a 3, the 3 becomes a 1, the 9 becomes a 3. And then you have 1/7 times 2/3, and then immediately just becomes 2/21. Notice that it doesn't matter which way you do it, but sometimes reducing first, especially if you're doing it by hand, makes the problem easier because the numbers stay smaller. Okay. So I actually want to interject a fun little problem where reducing first really helps. Okay. So how do you do this problem? Yeah. Right. You would never in your right mind do 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 and then put that over 2 times 3 times 4 times 5 blah 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 blah. You would never do that first. Right? The clearly the right thing to do is cancel, cancel, cancel. And you can immediately see that this works out to 1 over 13. Yeah? Yes. Right. So I'm thinking of it all. I think of it all as one big fraction. So it's lots of stuff multiplied together over lots of stuff multiplied together, and everything in the top cancels except the 1, or cancels to a 1, and everything in the bottom cancels except the 13. So you get 1 over 13. Think of it as just one big fraction. Okay. So that's a fun little reduce first business. Okay. Now, so you said, what about this cross multiply business? All right. So cross multiplying, or the thought of cross multiplying, comes from different places. So before I get to that directly, I want to talk about why. Because I think everyone remembers, oh, when you multiply fractions, you just multiply across, or there's some sort of multiplying going on. But I want to talk about why it makes sense and where it comes from. All right. So the explanation I'm about to give, some people may have seen it before, but some people may not have. So there's a picture that goes along with adding fractions, and there's a picture that goes along with multiplying fractions. Okay. So on the left side, I'm going to draw the picture for how do you add fractions using pictures. So what would the picture look like for 1/4 plus 1/2? Well, let's see. So here's the pie, and it's got a 1/4, and here's the pie that's got a 1/2. Now, how do you add these together? Right, so you put that into that, but then how do you figure out what the answer is? Aside from clearly the answer is 3/4, just from looking at it. Exactly. So the first pie is really, it's in a sense broken down into 4 pieces. So we've got quarters, and we've got one of them shaded in. The second one, the way it's currently configured, is that you have half the pie. But if you want to combine these together and figure out what they are together, what do you have to do? You have to make it so that both pies are cut into quarters. Why quarters? Because 4 is the LCD. So once you do that, once you divide the second pie into quarters, it's very obvious you've got 1/4, and then you got 2/4, so altogether you have 3/4. Alright. So is that one straight? Alright. Now that is how addition works, where we're combining stuff, getting more and more. Multiplication, different. How do we represent multiplication on a picture? You absolutely can. Sure you can. Okay. So if I wanted to represent, for example, 6 times 8, how would I represent that using a picture? Exactly. You draw 6 8 times, or if you like, you draw a box that has length 6 and width 8. Or you can do 6 rows of 8, or however you like. Something that represents, in a sense, well, actually the way you said it is that we were counting things. I'm going to think of it in terms of area. Because if you have a box that is a length of 6 and a width of 8, what's the area? How do you find the area? 8 times 6. So area is the same as multiplying the two numbers together. Okay. So the thing is, we can also represent the same thing using when we're dealing with fractions. How do we do that? Let's check it out. So here we've got a box. Now on the box, each side has length 1. So how do we represent 2/3? Well, if the whole, yeah, so this whole side is 1, and this whole side is 1. So let's represent 2/3 on the vertical side. So, no. There we go. Okay. So how do you represent 2/3? Well, first you have to take the whole thing, break it down into thirds, and then we've got two of those thirds. So this is now 2 out of 3, 2/3. You dig? So the length, so I've now, if you like, I've now got a side, I've now drawn a length that is 2/3. Okay, next, across the top, I want to represent 4/5. So how can I represent 4/5? Got to break it down into 5. 1, 2, 3, 4, 5. And I want something that's 4/5 long, so there you go. So now I've shown one, I've drawn one, make that a little thicker. So I've now got one side length 2/3 and one side length 4/5. So how do I represent 2/3 times 4/5? I draw that box. So whatever the area of that box is 2/3 times 4/5. Does that make sense? In the same way you'd be doing 6 times 8, only now we're dealing with fractions. So the question is, what's the area of the green box? Well, you can figure out what part it is of the whole box. And remember, the whole box was 1 by 1. So the whole box just represents one square unit, if you like. So how can we do that? So what piece of the whole box is the green box? How many pieces have we broken up the entire box into? 15. And where did the 15 come from? 3 times 5. And how many pieces of that is the green box? 8. Well, check it. It's 8. And where did the 8 come from? 2 times 4. So this is why we actually multiply across. If you like, when you're multiplying a fraction that's 2/3 times a fraction that's 4/5, the entire thing is going to be broken up into 3 times 5, or 15 pieces. And how many of those pieces are we going to have? 2 times 4, which is 8. So the entire fraction winds up being 8 over 15. So this is a visual demonstration of why we're doing what we're doing. Why it makes sense to multiply 2 times 4 across, and that gives you your numerator. Why you multiply 3 times 5 across, and that gives you your denominator. Okay. So who has seen this explanation before? Okay. So this also, so Tracy, you had said something about cross multiplying. So this is a clear explanation of why we multiply just directly across and why that makes sense. Okay? Okay. Alright. So lastly, we have to talk about division. So how do we handle division? Well, what if I said, what is 8 divided by 4? Alright, so we know it's 2, okay, fine. But what is another way of writing 8 divided by 4? We can just write it as a fraction. And how would you write that as a fraction? 8 over 4. But what I want to convince you of is that 8 over 4 can also be written as a multiplication. 8 over 4 excuse me, is the same as 8 times what? It may help if you think of it as 8 over 1, I don't know. But does that make sense? Everyone, does that make sense? Okay. So what I want to do is I want to use this example to convince you of that technique that we always use. 3 divided by 2/5. What are we going to do in order to make this a problem that we like doing? Sorry? Right. So we all remember the technique, but why are we doing this? Well, what did we just show? We just showed that 8 divided by 4 is the same as 8 times 1/4. Well, where did the 1/4 come from? What did we do to 4 in order to make it 1/4? You made it the reciprocal, exactly. Because what is 4? What is the number 4 as a fraction? This is really 4 over 1. So what we really did was, instead of dividing by 4 over 1, we said we're going to multiply by 1 over 4, the reciprocal. Alright. So this is easier to see when we're dealing with whole numbers, but the same principle works when you're dealing with actual fraction-looking fractions. So instead of dividing by 2/5, what are we going to do? Multiply by 5 over 2, the reciprocal. And then what is this equal to? Right. If you like, you could think of that as 3 over 1, And now we know from previous, we just multiply across. So that's just 15 over 2. Okay. So I haven't proven anything, but I've shown you why it makes sense based on things that we certainly are obvious. 8 divided by 4 is the same as 8 times a quarter. That much is clear. But I want to convince you that we can always use that idea. So that dividing by something is the same as multiplying by its reciprocal. The reciprocal for 4 is 1 over 4. And then in the other problem, the reciprocal for 2/5 is 5 over 2. So I like going through these things because a lot of people just remember flip and multiply, but you have no idea why you're doing that. So this at least gives, if not a proof, then a little bit of an explanation why doing that thing might just make sense. You dig? Okay. And then a final note about this last problem. If you do this on a calculator, be very careful. Because if you type this into a calculator, how do you type it in? Well, the instinct is to type in 3 divided by 5, 3 over 2 over 5. But if you do that, you'll get the wrong thing. Calculators are very bad at handling this. If you type it in not carefully, what the calculator will do is 3 divided by 2, and then whatever that is, divided again by 5. And that's not what we want. You could either change to a decimal, or if your calculator has parentheses, you can use parentheses. So 3 divided by, in parentheses, 2 divided by 5, for example. But my point is that you have to be careful when using a calculator in general, but in particular for a problem like this. Yeah, so with some calculators are better at handling it than others, but then of course you have to know exactly how to type in the right thing so the calculator knows what you're talking about. Okay. Next, decimals. 0.34 is a decimal. Okay. 0.01 is 1/100th of a dollar. If you like to think of it in terms of money. All right. So we're going to talk about this in a bit, but there's a connection between decimals and fractions. Now, before we talk about that, I want to talk about place value when it comes to decimals. So imagine that. So each A, B, C, D, E, F with the decimal point over there, each one represents a place value. Now, what's the place value for where C is? That's 1. What's the place value for B? Tens, and for A, it's hundreds. So those, we know those are simple. Now, what is the place value for D? Tenths. So 1 over 10. What is the place value for E? Hundredths. 1 over 100. What's the place value for F? Thousandths. 1 over 1,000. Okay. So when working with decimals, obviously if just using a calculator, the calculator takes care of everything for you. All right. But I want to talk about this by hand so we make sure that we understand what's really going on. Now if you do 0.23 plus 0.59, how can you work this out? Good. How do you do that? Okay. Okay. So 3 and 9 gives you 2, carry the 1. That's an 8. And then where does the decimal go? Okay. So this equals 0.82. So this one was relatively straightforward. What about this one? 6.4 plus 0.392. 6.4 and 0.392. So what gets added here? What do I write down? Where the zero? Where's zeros? Where? Oh, okay. Okay. So quite so. Anytime you can always put zeros in places after the decimal, and it won't affect anything. And you can put you can run zeros when you're on the left side decimal. You can just run zeros in there, and it won't affect anything either, if you like. So now we can add this. This is a 2. This is a 9. This is a 7. So 6.792. Okay. In particular, notice what we did. We said we're going to add up what's in this place. That place value is thousandths. So in this case, we've got 0 thousandths plus 2 thousandths. That gives 2 thousandths. Same thing in hundredths. Then in tenths, we actually got business going on. 4 tenths plus 3 tenths gives us 7 tenths. So in a sense, lining up, when you're doing addition, lining up the place values, what you're doing is you're saying, show me where the denominators are the same. Where am I talking about tenths? 4 tenths plus 3 tenths gives me 7 tenths. You would never add the 4 and the 2, because the 4 represents tenths, but what does the 2 represent? Thousandths. You wouldn't add those and get 6 of anything. Does that make sense? Okay. Alright. So now some more about connecting fractions and decimals. Alright. So what is 0.3 as a fraction? Right. That one's easy because we say it's 3 tenths, so we know it's 3 over 10. What about 0.79? Okay. Right. So one way to read it is 7 tenths and 9 hundredths, but you could also just think of it, everything as hundredths. 79 hundredths. So 0.5237. Over what? Right. Okay. So common mistake here is to say, oh, I've got 4 decimal digits, so it's going to be over 1,000. But that's not right. Notice that that would be approximately 5, which is not what we have. So that's the thing with decimals. A lot of people make mistakes about well, the order. But notice that it's 5 tenths, 2 hundredths, 3 thousandths, 7 10,000, 10 thousandths. So what we've got is this thing out of 10,000. Okay. So estimating can be helpful. Yeah. Yes, absolutely. Absolutely. Right. Right. So we've gone 4 places after the decimal, so we're going to have 4 zeros in our number in the denominator. Okay. So about 374 over 100. What is that as a decimal number? $374. Where does the decimal go? Yeah. Because, and this goes back exactly to what Jonathan said before. Dividing by 10, or in this case powers of 10, is the same as, or multiplying by them, is the same as moving the decimal 1 space each time. So note, if you go back to the previous problem, 5237 divided by 10,000, all that means is that we're going to move the decimal point how many places? Well, in the previous problem. we're going to move it 4 places. There are 4 zeros. So it's like starting with the decimal point here and and going 1, 2, 3, 4. Only now we're doing it directly. We're dividing by 100. So how many places is that going to move the decimal? It's going to move it 2 places. And we're dividing by 100, so it's going to move it 2 places to the left to make the number smaller. Okay. Next, percents. Okay. There you go. All right. First, a little bit of linguistics. What does per mean? Each. Okay. So in English this would mean each. What does this mean in math? When you see per, in math, what do you do? Right, you put it out of something. And what does that mean? What operation is that? It's division. Exactly. Cent. Yes, in English this is a penny. But what does this mean in other languages? If you say it in French, cent is 100. It's and what is it in Spanish? Cien. Okay. So it's the same thing. So if you say percent in Spanish, it's para cien. So that's all. So all percent means is divided by 100. So when you say 46%, just translate that into English. 46 divided by 100. It tells you directly what you're supposed to do if you understand language. So that's actually where the word percent comes from. So 46% just means 46 divided by 100, which is 0.46. Okay. So what is 5%? Now what is this as a decimal? Yeah, where does the 5 go? It is not 0.5. It's 0.05. Remember, 5 over 100 is 5 hundredths. So where does the 5 go? 5 goes in the hundredths place. This is one of the most common mistakes. Is to say I've got a 5, so I'll just put 0.5. And that's not it. 0.5 is what percent? 0.5 is not 5%. Yeah, exactly. It's 50%. Because percent is out of 100. So 0.5 is, if you write 0.5, that's not 5 out of 100. That's 5 out of what? Right. So, sorry, before we get to the next problem. 0.5 is 5 out of 10. But if we want to think of this as a percent, we have to make this out of 100. So out of 100, what is this? This is 50 out of 100. So it's 50%. This is why typically, particularly when we're dealing with retail or when we're dealing with money, we don't write $0.5 or 0.5 whatever. What do we typically write? We typically write 0.50. Because when you write 0.50, you immediately know that you're talking about 50, you're in the hundredths place, so you can immediately interpret that as 50 out of 100. 0.5, we tend to interpret that as 5 over 10. But since we like talking about percent so much, a lot of times we write things to 2 decimal places, which would be 0.50. Okay, so that's a really, really common mistake. Does that make sense? Okay. Next, what is 30% of 60? How do we figure this out? Okay. So let's convert this to math. So what are the things that we can convert to math directly? So first of all, 30%. How do you write 30% in math? Right. So that's what we've been talking about. That's 30 over 100. Okay. Now, of course, 60 is just 60. What else can we convert into math? Of. What is of when you convert it to math? It's multiplication. What else can we convert into math? When you convert is into math, what is that? Equals. Right. There you go. And this is now very simple. Now we just have arithmetic to do. So you get 30 over 100 times 60. So now naturally we're not going to do 30 times 60. We can simplify a little bit first. So how can we simplify? Yeah. So what you've got is this, and you can just divide by 10 gives you that. Divide through by another 10 gives you that. So it's just 18. You can come up with whatever shortcuts you like. I'm doing it rigorously, slowly, step by step. Okay. So this is percents. Okay. Now, this is a trickier one. 12 is what percent of 96? You can freestyle it, but we can just convert this directly into math. So 12, rewrite as 12, then what? No. What's the next word? And how do you write is in math? Is equals. Then what? What is x and what's percent? Divided by 100. Of is times 96 is 96. So the thing is, if you don't know what you're doing, these two questions look basically like the same question. What is 30% of 60? 12 is what percent of 96? They sound like they're both percent questions with two numbers. But all you have to do is convert them word by word into math, and it's very straightforward. Okay. So now we can solve this. So you've got 12 equals, if you multiply across, you get 96x over 100. So how do we finish solving this? Okay. So I would say I don't like fractions. Let's get rid of the fractions. So to get rid of the divided by 100, what do? Right. So multiply by 100 on both sides. Now another way of thinking about this is cross-multiplying. So the end result is that you have 12 times 100 and then 96x left over. So the shorthand for this is saying let's cross-multiply, but notice that cross-multiplying is the result of doing something to both sides of an equation. So cross multiplying is something you do when you have an equation, not when you're trying to multiply stuff or when you're trying to reduce a fraction or whatever. So this is why I even hate cross multiplying, because people tend to use it when it shouldn't be used. Okay, so now what do we do? Right. So now we divide by 96 on both sides. Right. And what is that? Okay. So there you go. So the answer is 12.5%. All right. So again, Terrell was sort of like freestyling it, like saying, "Oh, hey, I think you can set it up like this." But notice that you don't need to sort of guess about how you can set up the original statements. You can simply translate it directly with these simple questions. You dig? Okay. So one last thing for today. Converting between, here, let's go one at a time. Converting between fractions, decimals, and percents. Alright. So 0.12 is a decimal. How do you write that as a fraction? 12 over 100. And let me just say ahead of time, for our purposes, I don't care if you reduce or not. Okay. What is this as a percent? This is 12%. That one's easy. What about 1.32? What is that as a fraction? 132 over 100. Because it goes to the hundredths place, so it's over 100. Now what is this as a percent? This is 132%. Notice that this makes sense, because what is 1 in terms of percents? It's 100%. So notice our decimal is slightly more than 1. So our percent should be a little more than 100%. So usually when we talk about percents, we're talking about like from 0 to 100%, but we don't have to. I could talk about 937% if I want. This is what it means. Okay, next. 5%. What is 5% as a decimal? Point what? 0.05. And what is this as a fraction? .56. Oh, we already did something like this. That's just 56 over 100, and as a percent, that's 56%. Okay. Okay. 24.6. What is that as a fraction? 246 divided by what place value does it go to? Tenths. So it's over 10. Do you see where that comes from? Because where's the 0.6? What place value is that? It's in the tenths. So we could think of all these things as out of 10. Okay, now what is this as a percent? Nope. Nope. This is 2,460%. Because how do you go from a decimal to a percent? What do you have to do with the decimal point? Two places which way? To the right. In the same way that when you have a percent and you're going to make it into a decimal, which way do you move the point? Okay. Just because it's 24.6 doesn't mean, oh, that must be a percent, so let me move it to the decimal point 2 places to the left. That's the wrong thing to do. That is a decimal. What is that as a percent? The number is 24. What is 24 as a percentage? It's 2400%. Because it's 24 wholes, approximately. You dig? Okay. So don't let your conventions of the numbers that I'm used to working with, don't let that override what you're supposed to do. Okay. 5/8. What is 5/8 as a decimal? So how can we figure this out? Oh, other way around. 5 divided by 8. And how are you going to figure out what that is? Use a calculator. Thank you. That's it. You can either do it by hand, but we're not going to go through all those things. 0.625. Now, knowing that, what is this as a percent? Okay. About 1/3. What is 1/3 as a decimal? And it goes forever. Yeah. So what is this as a percent? Not 33%. Absolutely not. 33.33 blah 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 percent. Okay. If you write 33%, I will mark it wrong. If you write 33.3%, I will mark it wrong because that is not what it is. It is 33.333, etc., etc. Okay. Yeah, Jonathan. That means repeating forever, so that's correct. Right. There are two ways to write goes on forever, either the bar or the dot dot dot. Right. Okay. Then there's 1/7. 1/7 is a lot of fun. As a decimal, it is 0.1428357. Oh, there's no 3? It's just 28. It's 2857? Okay. Wait, 142857? I will show it to you. One 428.142857, 142857, 14. All right. Well, you know what? The spreadsheet failed. We know what it's supposed to do. It's 142857. It stopped calculating it for a reason I don't know. Okay, but there you go. So 1/7 is a really fun fraction. Okay. So there's a little more about fractions and repeating decimals in the text. I'm going to leave that as extra credit material.
Isn't it like 14.2857 yada yada percent?
Yes. Okay. And I'm sorry, one last comment. I'm sorry, just bear with me for another 30 seconds. So I believe I mentioned this before. When do we prefer decimals? Well, in one class, 20 out of 23 students passed some exam. In another class, 15 out of 17 students passed. Which class has the higher pass rate?
The first one.
Are you sure?
The second one. Yeah, the second one.
Well, the first one is 20 out of 23. The second one is 15 out of 17. So it's easy to write as fractions. But are they easy to compare as fractions? No.
I see.
Right. So it turns out the second one.
Bigger numbers.
Alright. So, when do we prefer fractions? A class has 7 students and 3 male. What part is female? It's very easy just to write down 3/7 instead of, as we've seen, 42.857 blah 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 percent. So you can never say which is better, a fraction or a decimal. It depends on what you're trying to do. Okay.